Hello people. Right, continuing with this little amp project. In a previous upload I mentioned that it was around about between 2 and 3k is the bias that's comes from the collector. This is collector based biasing, and it's a resistor. It worked out between 2 and 4k, so I found a 3.3k in my collection, which I'm just about to connect. Out of pure curiosity, interesting to get this thing up and running like that. Curious actually what resistance. To 20 volts. Okay, so we connect that to the negative rail like that, and on the meter, whoopsie daisy, on the meter, sorry about all this wobbling picture and stuff, 3 volts. Let's lose that. Always check the HD voltage, it's always a good idea, supply voltage. And just out of curiosity, I wonder what, if it works out to be 1.5 volts, 2.38, that's on the actual transistor collector to emitter junction. So if we actually measure across the speaker, we'd imagine it might be half because it's just a resistive load. I don't know the reasons why, but it's 0.6 volts. Now, mostly concerned with just current flowing through the speaker and the emitter collection junction. So now we're interested in finding out a value for the previous stage. I call it the intermediate stage. That will be preamp intermediate output. So let's pop the potentiometer in. Always max it out like that, so it's the highest resistance setting. Pop that under there. Now, in order to get the maximum possible voltage swing at this point here, so the actual transistor is going to try and pull the voltage down and increase the current through this load resistor. And when the resistance of the emitter collector junction goes high, that means there'll be more voltage across the load resistor. So we need to get half the supply voltage at this collector. So we shall connect that there and connect to the ground like this. Hope it's all in the shot. Then we can decrease the resistance, which will increase the amount of current flowing from the collector circuit to the emitter. So we're on 1.84, going to decrease the resistance until we get 1.5 volts. So that's half VCC. VC is half VCC. 1.49. I mean, well, that's 1.5 volts. Now we can disconnect the battery, power down, disconnect without turning the knob, of course, that must remain stationary. Then we turn the to 200k, and then we take a resistance reading between the two connections. 7.4k. That's not really a preferred value. So what we're going to do is try to get away with this one, which is, I think it's, looks like 6.8k. Let's see if that will work. I think it's 6.8k. The old sockets are playing up, eyes. So I'm actually finding a bit of difficulty seeing these things. There we go. It's a little bit lower. I mean, I suppose I could get a 75k resistor, but 68 is very close. It's the nearest preferred value in the E12 range. So we connect that between the collector and the base. Take a voltage measurement at the collector. Whoops, popped off. And see what we get. Reassuring pop. Of course, I've forgotten to take that off her ohms. Easily done. Well, that's my excuse. 1.46. Well, it's popped out again. Sorry, said the actress to the bishop. There we go. Let's give us a little bit more looseness. There we go. 1.45, so that's near enough half supply voltage within a reasonable tolerance. The next job, I think, would be to make a connection between the collector circuit output of this amplifier into the base. So that will come soon. Thank you for watching. Bye.